Now let's take a look at two more examples of solving one-step linear equations. These are slightly less straightforward, so that's why I wanted to discuss them separately. First example that I wanted to talk about is this equation, negative x equals 22. The reason why this equation is sometimes problematic for students is because when you look at this term negative x, it's not as easy to say, well, what is happening to x? What is going on with x here? And remember, your answer has to have some kind of a verb, right? Something was added to x, it was subtracted from x, x was multiplied by a number, x was divided by a number, right? It has to be something. But we don't see a number, we just see this minus sign here, which can be a little bit confusing. What would make this easier is if you remember that saying x and saying 1x is really the same thing, because 1 times x is just x. And while adding the 1 doesn't change the value of the expression, it does make it clearer what's happening to x. What's happening to x is multiplied by negative 1. Well, now things are kind of easy, right? Because we know how to undo multiplication, we divide. So what we want to do is we want to take the negative 1x, or the negative x, and divide it by negative 1. And do the same thing with the right side. Take 22 and divide it by negative 1. That way the negative x, or the negative 1x, if you like, the negative 1's cancel, leaving you with just x equals, and 22 divided by negative 1 is negative 22. And so we have our answer. X is negative 22. So this is how you want to approach a problem like that. If you see that you have minus x equals something and you want to get rid of the minus sign, remember this minus sign means multiplying by negative 1. Now let's take a look at another example. 3/5 x equals 11. The only thing that makes this example even slightly different is the fact that what x is being multiplied by is a fraction. And so let's talk a little bit about what to do here. Since x is being multiplied by 3/5, the way we undo is we divide by 3/5. So 3/5 x divided by 3/5 equals 11 divided by 3/5. I'll write the division not in fraction form, but this way to make clearer what will happen next. Now 3/5 divided by 3/5 will cancel out, leaving us an x. We knew this was going to happen, that's why we chose to divide by 3/5, right? We're trying to undo the multiplication. On the other side, I'll continue over here. How do we divide fractions? Remember, we keep the first number 11, and we can write it as 11 over 1 to make it in fraction form. We change division to multiplication, and we flip the second fraction, 5 over 3. And then we multiply the two fractions. There's nothing to reduce, so we can just multiply straight across. 11 times 5 is 55, and 1 times 3 is 3. So x is equal to 55 over 3. Again, in both of these examples, it's pretty easy to look at your answer, plug it back in to make sure that your work was correct. So for example, in this problem, the equation was negative x equals 22. If x is negative 22, then we have negative 22 equals 22. Of course, minus minus cancels. So this solution works. And similarly, if I say my answer is 55/3, the equation was 3/5 x equals 11. If I plug 55/3 in for x, I have 3/5 times x, which is 55/3. And remember that before multiplying, we want to see if we can reduce the fractions. We can divide the top and bottom by 3. And here we can divide the top and bottom by 5, giving us 11 and 1. And we're left with 1 times 11, which is 11/1. So again, our solution works. For those of you who had trouble following this simplifying that was done in this step, I suggest that you look up cross canceling as a topic when you are looking at multiplying fractions. It's going to be a very useful topic for us later on, and you will need it when you move into Math 118 as well. All right, so our next video, we're going to look at equations that have more than one variable.